Hello everyone, welcome to Ops by Yash. So in our previous video, we understood the Docker container lifecycle. How a container is created, started, stopped, restarted and finally removed. But there is one more important question. Where does the image actually come from? Because remember, a container cannot magically appear out of thin air. If I run docker run nginx, Docker needs the nginx image first. And if that image is not available locally, Docker needs to download it from somewhere. That somewhere is called Docker Registry. Think of a registry as an online warehouse for Docker images. Your image is the product, the registry is the warehouse, and Docker is the delivery guy. The most popular registry you will encounter is Docker Hub. But in real DevOps environment, you will also see private registries, and understanding the difference between these two is extremely important. Before we go further, let's clear up four terms that people very commonly mix up: image, container, repository, and registry. A Docker image is the packaged blueprint of your application. For example, nginx latest myapp 1.0. The image contains the application dependencies, libraries, configuration, and file system layers required to create a container. Then comes the container. A container is basically a running instance of an image. Now, repository. A repository is where related versions of an image are organized. For example, Yash myapp. And inside that repository, you might have myapp 1.0, myapp 2.0, myapp latest. Those are different tags pointing to image versions. And finally, the registry. The registry is the larger system that stores and distributes those repositories and images. So remember this hierarchy: registry, repository, image, container. Actually, technically, the container is created from the image, it does not live inside the registry. And that's an important distinction. The registry stores your images, your Docker host creates and runs the containers. Now let's talk about Docker Hub. Docker Hub is essentially a host container registry provided by Docker. It allows developers to store, share, discover, push, and pull container images. And this is probably the registry you will interact with the most learning Docker. For example, when you execute docker pull nginx, Docker normally looks to Docker Hub unless you specify another registry. Docker downloads the image layers and store them locally on your machine. Then you run docker run nginx, Docker can create a container from that local image, and this is why Docker feels so magical. You say one command and suddenly nginx has moved into your laptop without paying any rent. Now Docker Hub repositories can be public or private. A public repository can be pulled by everyone. A private repository is restricted to users who have those permissions. Docker Hub also supports things like repository access controls, webhooks, automated builds, and image security features. So Docker Hub isn't simply a folder full of images, it's a complete image distribution platform. Now let's understand the most important workflow. Imagine I have built my application locally. I created an image using docker build command, and now the image exists on my local machine. But my teammate's laptop does not have it. My production server does not have it, and Kubernetes don't have it. So I need somewhere to store and distribute that image. That's where the registry comes in. First I authenticate through Docker login. Then I tag my image with the repository name using docker tag command. And first I authenticate using Docker login. Then I tag my image with the repository name, and then I will run docker push. Now my image is sitting inside the registry. My teammate can simply run docker pull command, and then they get the image, and then they can run docker run, and now they are running exactly the same application image. This is one of the fundamental ideas behind containerized deployments. Build once, store once, distribute anywhere. And notice something important. We are pushing an image, not a container. You don't normally push your running container to Docker Hub. You push the image from which containers can be created. Now the big question. Why would a company need a private registry if a Docker Hub already exists? Imagine your company has an application called Banking API. Now, would you really want to upload that company's internal production image to a public repository? Probably not, unless your career goal is to become extremely popular with your security team. That's where a private registry comes in. A private registry is controlled by your organization. It can be hosted inside your own infrastructure or provided as a managed private registry service. For example, registry.company.com. Your image could be registry.company.com/banking-API 1.0. Now, only authorized user or systems can access it. This gives organization much more control over authentication, authorization, network access, image storage, security policies, and who can push and pull the images. So the basic difference is Docker Hub is a hosted public-private registry platform, and private registry is an organization-controlled registry environment used to keep images restricted to authorized user and system. And in enterprise DevOps environment, private registries are extremely common. Now let's go one level deeper. When you push an image, Docker does not simply upload one giant file called myimage.zip. Docker images are made up of layers. For example, your image might contain a base operating system layer, a dependency layer, your application layer, and configuration or metadata. When Docker pushes the image, those layers are uploaded to the registry. And here is the clever part. If the registry already has a layer, Docker does not need to upload the exact same layer again. This makes image distribution much more efficient. When another machine performs a pull, Docker retrieves the image's metadata or manifest and then downloads the required layers. This is also why you will often see output like already exists during push or pull. Docker is basically saying, relax, I have already got that layer, and this layer based architecture is one of the reasons Docker images can be efficiently distributed across environments. Registries can also use digest to identify immutable image content. For example, my app @SHA256 and so on. A tag like latest can move to different image versions over time. A digest identifies a specific image content. That distinction becomes very important in production deployment. Now let's connect everything we have learned. A developer writes code, then we build a Docker image using Docker build command. The image exists locally. We tag it using Docker tag command. Then we authenticate with the registry using Docker login. Then we push it using Docker push command. The registry stores the image and its layer. Now our CI/CD pipeline, server or Kubernetes cluster can pull that image using Docker pull command. And then finally we can run Docker run that creates the container from that image. So the complete flow would be first we code, then build the image, then tag the image, then push it to the registry, and then the respective systems will pull those images and create a container from that. This is the bridge between Docker development and real-world DevOps deployment. And one final thing to remember, Docker Hub is not the only registry. You can have private registries inside organization, cloud-based registries, or even run the open source Docker distribution registry yourself. Docker's official registry image can be run locally, for example, on port 5000. So now you know where Docker images live, how they move between machines, what Docker Hub does, why companies use private registries, and how images travel from a developer's laptop all the way to the production. But we have been talking about commands like Docker build, Docker tag, Docker login, Docker push, and Docker pull without actually getting our hands dirty. And that's exactly what we are doing in the next video. We are going practical. We are going to take Docker commands and actually run them. We will cover the important Docker commands, creating containers, starting them, stopping them, restarting them, listing them, inspecting them, removing them, and many more things. Basically, no more I know the command. We are going to make sure you can actually use the command. So if you are following the Docker Fundamental series, make sure you don't miss the next session, because that's where Docker goes from I understand it to I can actually do it. See you in my next video. Please subscribe to my channel.